Today we will discuss about preferred numbers. What are these? See, when you go to shop and when you try to buy a product, let us say an electric LED bulb or a pump or an electric motor or any other product, you would see they will be available only in certain capacities, certain ratings, right? So how do we get those ratings? So these are obtained by using the concept of preferred numbers. So these are basically standard guidelines for choosing the exact product dimensions, right? So the product dimensions are specified in terms of different parameters. Like as I said, size, power rating of electric motors or pumps, similarly bulbs, load carrying capacity when you have a truck, right? So each truck will have a load carrying capacity, 5 ton, 10 ton, and so on. You take any testing instrument, right? So the maximum load that you can apply onto the specimen will be limited. For example, in RUTM, it goes up to 400 kilonewton, right? Similarly, 5 kilonewton machines are also available. 5 Newton machines are also available. These are all the different loading capacities of the testing instruments. Speed, take any vehicle, the maximum speed that it can achieve, right? 120 kilometer per hour, for example, any two-wheeler, right? Four-wheeler, maybe beyond that, and so on, right? So these will be decided based on the constraints. So the constraints include the functionality, compatibility, safety, or cost. So based on these parameters, we decide these things. So why do we use these preferred numbers? Because it will reduce the number of sizes and variety of items with a view to reduce the cost and improve the quality. For example, can we have an LED bulb ranging from 1 watt to 100 watt, covering all the values, including decimal values 1.1, 1.2, 1.3? It is not possible. In that case, I will have infinite number of varieties. So then to manufacture those infinite number of varieties, I need to have different machines sometimes, which is not at all possible. And ensuring quality on that is very, very difficult, right? Somewhere we need to standardize. So by using preferred numbers, we can cover the complete range with minimum number of sizes. So which is of beneficial for both the consumer and as well as the producer. So this concept was basically invented by the French balloonist Charles Renard in the 19th century. So how does, one moment. Third term of the R10 series is actually 1.6. Sorry, R10, right? R10 is actually 1, 2, 3. It is actually 2, the third term. First term, you please ignore that 1.00, they're all default one. So 2 will be used in generating the series, right? So you know how to generate the series, making use of 2, multiply with the 2, and so on, okay? And there is one more series, one more way of deriving the series, R20 by 4. What does it mean? They are making use of fourth term of R10 series in building this. So a series which includes only, which includes 8, right? But there is no upper limit and lower limit. So this is one way. The other way is a series which has only lower limit, not the upper limit. How do you build that series? Making use of third term of the R20 series. Similarly, a series with upper limit only, no lower limit. You can start anywhere. So making use of third term of R20, we will generate that series. Okay. That is first method. Second method is obtained by just increasing the numbers of a particular basic series. How to get that? So let us take an example. So we want to develop a derived series with numbers ranging from 1 to 1000 based on R5. So from our table, what is R5 series? R5 series is 1, 1.6, 2.54, 6.3, 10. So what I do is now I multiply the next number. So these are the first 5 terms. From 1 I have to go till 1000. I'm going to get the next term just by multiplying 10 with the existing one, okay? we have 10 already, so you don't need to multiply again with 1 to get one more 10. Okay, multiply 10 with 1.6 to get 1625, you reached 100. Next you should progress till 1000. Again you multiply this 16 by 10 to get 160, and finally you will reach 1000. So your entire series will be now this 1, 1.6, 2.5, 4 through 1000. So these are the preferred numbers of your series. This is the way to develop, the second way to develop the preferred numbers, right? Sorry, the series factor of R10 is 1.26, so you go, or 1.25. Okay, so you multiply 1.25 100, you will get 125, and then so on. Okay, these are all rounded off to nearest integer value, right? So we got 11 shafts. So third problem, it has two parts basically. So a manufacturer is interested in developing 5 different models of tractors whose capacity is ranging from 7.5 to 75 kilowatt. 5 different models. Remember, we don't know the series factor now. We have to evaluate it. So we have to specify the power capacities. That is first part. So the ratio factor for this series factor for this range is different. The next part is he wants to expand it, okay, to increase the number of models from 5 to 9. In that case, what is the power capacities of the additional model? Again, the series factor for that case will be different. In either case, you have to evaluate the series factor like in the previous problem. So you have to write like this: 7.5 into 5 raised to 0 until the fifth one. Equate the 7.5 5 raised to 4 to 75 and calculate the series factor and generate the series. So this we know how to. Then you can round it off to the nearest integer, 13. If it is below 0.5, seal it down, else seal it up, floor it, seal it. So you have to learn those options, right? Now second, 9 models. Again you have to write a series like this. Equate 7.5 5 raised to 8 to 75. Calculate the series factor, right? Multiply like this to generate the series. You floor it or seal it wherever it is appropriate. Get the additional mod. The additional models are 10, 8, 32 and 56. The remaining we have already calculated previously. So this is about preferred numbers. Okay.